Hi class. Some of you ask for information on how to set up a Scratch account and how to program with it. It's a great idea, so I'm going to set that up as a daily science assignment because just as I've been using it in class to show the steps of how all of this works, simulating this for yourself is going to be a fantastic way to learn how to do it. So I'm going to set up a new Scratch account. That's why I have in an incognito window so it doesn't recognize my old one. And you can see how all this works. So Scratch is done by MIT, and you just type in scratch.mit.edu. Okay, it is free to join, and Cantilever already exists. You need to select a password, write it down if you think you might forget it. You will need some email address. You will need some email address to associate your account with. Now, normally you don't give your real info on the internet. It is safe to do this with MIT. They are following all the laws related to maintaining information for a minor. There are laws in the United States about that, and so they are, as a university, as an educational thing for people younger than university age, they are doing those things. So I was born in 1969. So I will put that there. And you can put male, female, or fill in the blank. My daughter often puts robot. Or sometimes now she says her gender is clarinet. All right, this is where you're going to need an email address. I have to use it on a different one than my normal one. Use your parents, that is fine. I'll go ahead and receive updates. All right, so you can go ahead and get started. Now, until you confirm your email, you won't be able to do certain things, but what you can do is start your own programs. The thing you won't be able to do until you confirm your email is send and receive messages. So you can send and receive messages from people online, which is another thing to make your parents aware of when you do this. Okay, so the first thing you want to do is go to Create, and this should run in any of the major browsers. Notice I have to click to enable the Adobe Flash. That doesn't mean it's broken. Just go ahead and click and tell it to allow it. Alright, so here we are. This is called a sprite. You can add new sprites from the library, or you can make your own. Here's another sprite that we used, or since we're about to start talking about Newton and the apple, we could add an apple. You click on the sprite to then program what happens for that sprite. So I want to make sure I'm clicked on this sprite, and then you need some event to get everything started. It's usually green flag, hit space. You can have things do different actions when you click on them. Different stuff. There are tutorials on for a lot of this on the Scratch main page, which are great. I'm going to link to one of the tutorials from just to see where you can go with it. Now, under Data, this is where we make variables. You could make a variable for all sprites, and acceleration due to gravity would be a great one to set for all sprites, because you want to pick if these guys are on the moon or if they're on the Earth, it'll be a different value for acceleration. And as Megan points out, I do in my classes in programming, whenever we make a variable, we have a set things up or initialize function that we make. This is a different block. These are your own blocks. So here there are all these blocks, things that you can do, and then the purple ones are ones you can make. Now once you have to define it, we're going to set our acceleration due to gravity to -2. But then you have to do something called calling it, which means I have to drag this block over. I have to use the block. So now, when I click this, it sets that to -2. Okay. Now, another variable that we need to simulate falling is velocity in y. That's velocity up, down. This one I'm going to make for this sprite only. And I'm going to initialize it, set it to 0 at the beginning. Remember, Aristotle said said there was no acceleration. Aristotle said your velocity is set at the beginning and it never changes. Okay. A common mistake people make in they're going along programming just fine and they get their logic, which is our logic is going to be something about, or the steps that we're going to do, if we want to have a floor, a place where the cat's going to run into the floor, then we might have an if-then, and we need to have a little operator here, and this is like less than equal to, all these little things fit in there. So as long as his y position, just drop that in there, wait till it glows and then drop it, is greater than, let's say, greater than -114. Now I figured that out because I looked here and it's telling me where my mouse is over here, so I was able to go, oh, -114, that'll be good. As long as it's greater than 114, we want him to keep dropping, and then -114 will be the floor. As long as its y position is greater than 114, then I want to change, it's under data, change velocity in y by acceleration due to gravity, and then motion, I want to change y by velocity. Alright, let's pick this guy up. Oh, now look at this. This is what I meant about the common error. He's not falling all the way down. Why is he not falling all the way down? Well, he only goes through this once. So if we want him to keep going through this, then we need either a repeat until, wait, all those things. But what we've been using in class is the forever loop. You drag it over here, put it around, there we go. Alright, so now he falls till, he'll go past the -114 for a reason that has to do with how often he checks it. We are going to talk about this in Emily du Châtelet. It also has to do with the energy. Okay, so the reason why we would want to have we set this variable up as for this sprite only is we could have all these things falling and responding to gravity at the same time, and their velocity would have to be different. Their acceleration due to gravity would all be the same, but their velocity would be different. Now, another thing we did in the program was we added bouncing. To add bouncing, to simulate bouncing, if the cat hits the ground, we're going to set the velocity in y to the opposite. This is a times. We're going to take a -1 and go over to our data. Okay, do that. And then the part that I always forget is we're going to change y. I have to do that. I have to change y by velocity in y. All right. And there you go. All right, have fun with this. Bye.